All right, number 4 is pretty straightforward. It's talking about the moon. It's talking about a point on the moon that's rotating as the moon takes a full revolution every 27.3 days. At what point, you got this point on the moon, how fast is that moon moving around? We're trying to find the linear speed of that point as the moon rotates around on its axis. So V is equal to R omega, radius times angular speed. What's the radius for the moon? 1.079 times 10 to the 3 miles. Before you start going crazy, what do we know? You guys should know this from science. If we raise it times 10 to the third, that's going to move your decimal places 3 places to the right. So that's the same thing as 1079 miles. All right? And then they say 1 full revolution every 27.3 days. So 27.3 days. All right, but all of my answers here are miles per hour. So first of all, sorry, that's 1 revolution. First of all, I need to get rid of revolutions and put it into radians. So 1 revolution is 2 pi radians. But radians isn't really units, so I'm not going to put it up there. And then I need to go from days to hours. So I want day on top so that it will cancel out. 1 day is 24 hours. So now, revolutions cancels with revolutions, days on bottom, days on top, and I've got miles per hour left over. When you plug that into your calculator, you should be able to figure out whether it's F, G, H, or I. All right. Use this information to answer questions 5 and 6. A child is sitting on the edge of a playground carousel as it spins at a constant rate of 0.25 revolutions per second. The diameter of the carousel is 2133.6 millimeters. Be careful. Do we care about diameter in our formula? What's our formula? Linear speed is equal to radius, not diameter, radius times omega, which is angular speed. So if the diameter is 2133.6 millimeters, radius is half of your diameter. So your radius would be 1,066.8 millimeters. All right? First, they want us to find the angular speed, which we don't care about the radius for angular speed. They gave us a speed of 25 revolutions per second. So 0.25 revolutions per second. But all of my answers are in radians per second. So this is just a matter of changing revolutions into radians. Solving this guy here, you should be able to find out whether it's A, B, C, or D. And then they want you to find the linear speed. This is where we do care about that radius. So my linear speed is going to be my radius, which is 1066.8 millimeters, times my angular speed, which we said was 0.25 revolutions per second. Once you've figured out what 5 is, you can use whatever your answer is, but I'm not going to go ahead and spill the beans here. All right, I'm going to change revolutions into radians, 2 pi radians. Now I've got millimeters per second. They want meters per second. How many millimeters are in a meter? 1,000 millimeters in 1 meter. So that's what we're going to put into our calculator, because millimeters will cancel out here. Revolutions cancels out. Radians isn't really a unit. We've got meters per second, which is what all of our answers are in. Putting that guy into your calculator should be able to get number 6. All right, based off of this, I think you should be able to do number 7 just fine. So I'm not going to put that one in the next video. I think you should be able to do number 8 just fine. And we're going to come back, we're going to talk about 10, 11, and 12 in the last video.